Hey there, fellow MDRS engineers. This is Paul Bakken again. Just here with an update on the prototype airlock system that I was working on. I posted a video earlier with just a really rudimentary prototype done up on a breadboard with little lights and stuff. Wanted to fill you in on some of my progress. I've migrated the system to hardware that's deployable, and I've added a little bit to the code and some other functionality, so I thought I'd just check in with you. Anyway, this part right here is the controller box. It's got the Arduino board and a number of other things inside, and it's powered off of the USB port on the Arduino board. That's this black plug down at the bottom. That just goes into regular wall power. And in addition to the control module here, which would be mounted in the airlock itself, there are the user interface buttons. Now let me back up here a little bit so you can see that a little bit better. So there's the outer door ones, and there are the inner door ones. Now all of those module boxes are exactly the same, and they're meant to be interchangeable and easily swapped in and out and replace each other. But essentially they've got the cycle request button on them, and instead of having separate indicator lights, those buttons can be made to light up the different colors. There's an RGB LED kind of jammed up behind there in the micro switch mechanism. And the way that these hook up to the control box, I'm sending low voltage power and the data just over Ethernet cable, because the hardware was nice and cheap and readily available, easy to maintain and replace, and I only needed 8 channels of stuff, so it worked out pretty well. So yep, these boxes, they're made to be daisy chained. You can see that there's 2 Ethernet jacks on the bottom of each box. They're kind of wired in parallel essentially, so that you can plug into either side and it'll interface with the buttons and the lights and the buzzer that's in each box. But then you can hook up another cable and daisy chain another interface module onto it in order to extend the logic loop. And that right there, since that port's not being used, I just took an extra Ethernet jack, pulled out the metal bits and shoved a bunch of hot glue in there to make a little bit of a port plug to keep the dust out when that port's not being used. So that's the system. As I said, the control module ideally would be mounted in the airlock, and then on the outer doors, this interface button would go on the airlock side of the outer door. This would actually be outside on the EVA side, and mirror image over here. This is on the airlock side of the inner door to the hab, and this is on the interior of the hab side of that inner door. So, in looking at the control box, some people wanted a digital readout, some people wanted an analog dial. I figured, why not do both? So I put that together. This piece of hardware right here for the dial, I looked for enclosures for custom instruments, and they were really expensive. So instead, I just went to the hardware store, bought the cheapest air pressure gauge that I could find, pulled the gauge out, and then I'm just using the box. So the servo is mounted up underneath. I printed out a custom dial, and worked out pretty well. And then that's just a 4-digit 7-segment LED module, and I printed out a sticker to serve as a bezel. And then on the side, there's the data and power in and out up on the top there. And those little blue loops, those are just jumper cables. There's 2 small holes on either side. Those would hook up with these door sensor modules. Just haven't had time to get those in and working yet. Essentially the way those work is, it's a normally closed circuit. So when the door is closed, the magnetic part is close to the sensor. It closes the circuit, so it sends a high signal to the Arduino logic board. And of course, when the door is opened, that contact is broken and the signal goes low. For the time being, I'm just simulating that by having a jumper cable close the loop, and then when you open the door, you just pull one of those out close the door, put it back in. The polarity doesn't matter, so they can be hooked up either way. All right, so bear with me for a second here. I'm going to reach over here and plug the unit in to give a quick demo. Okay, so there's a little on message, and you can see that it's currently defaults when it's turned on to HAB ambient pressure, which is 1,000 millibars. And over on the HAB side doors, I'm getting a little glare off the window, but you can see they're lit up green, and the other ones are red. You shouldn't open those doors. So I'm going to go ahead and simulate somebody opening the door. You get a door ajar message, and those green lights flash just to let you know that there's something going on, and you shouldn't try and cycle the airlock with the door open, but just in case you do. Yeah, I don't know if you can hear that, but it gives you a little error sound. And I'll get this plugged back in. Yeah, sorry about the shaky camera. Kind of hard to do this and work with it at the same time. Okay, both doors are closed. I'm going to go ahead and, it doesn't really matter which button you press, but I'm going to go ahead and initiate a cycle. So you get the audio feedback. That digital pressure meter is counting down, and you can also see the analog dial slowly creeping to the left towards Mars ambient. During the cycle, you get the audible, at least on the inside, and all of the interface buttons flash red to let everybody know that there is a pressurization or depressurization cycle in progress. So right now I've got the time and the pressure gauge and digital readout increments kind of synced up to about a 30-second cycle, I think. Just because for testing I didn't want to have to sit there and wait for 3 minutes each time I tried stuff out. So the increments on the digital gauge, they're not quite matching up, but that's an easy programming fix. So we're just about done. Okay, so the cycle is complete. You can see that the analog dial now reads at Mars ambient, and the pressure indeed is 6 millibars. The outer doors now show green, good for access. The inner doors are red, and that is pretty much it. The logic of the Arduino, it can also handle, it's not going to prevent the doors from opening, but it will register and handle oopsie events like, say we've got, the doors are closed, you're equalized with outside pressure, but let's say somebody foolishly opens the HAB door. Okay, we had an explosive recompression event, and we get the door ajar, flashing green on that side, assuming that you survived the event, and red on the other side. So it'll handle those explosive compression or decompression events going in either direction. And then there's also a series of custom messages where if you're foolish enough to open both doors at the same time, it'll give you an error message, and there's really no way to recover from that except to shut all the doors and reset the system. So that, in a nutshell, is what we have going on here. I'm hoping that if the engineering team gives this the green light, we might even be able to do a trial deployment during my crew's upcoming rotation. If not, it might be a candidate for something to try out during the engineering rotation in October. So that's the system. If you have any questions, please let me know, and I'll do my best to answer them. And just as we wrap up here, I'll show you that final event that nobody ever wants to see. Okay, it says HAB air gone, close doors, and reset system. And it just kind of keeps doing that until you reset the system. So again, that's it. Please let me know what you all think, and we'll talk to you soon. Thanks, guys.